Hi, this video is for section 7.5. It is called Multiply Special Polynomials Using the Area Model. These are considered special polynomials because all the examples you're going to see today have some sort of pattern or shortcut that you could use to solve these. But to be totally honest with you, I sometimes think those patterns and shortcuts are confusing if you don't really see them, and you end up making mistakes. So we're just going to stick with the area model today as we go through these four examples. One thing to note, this very first slide is a super common mistake that students make, so I wanted to talk about it a little bit. This guy right here, x plus 3 squared, that's a binomial inside, x plus 3 because it has two terms. This guy over here, there's some invisible math going on. Hopefully you recognize that there's multiplication going on. 3 times x, so that means there's only one term here. So this is a monomial squared. Now, really when you see this squared, what you want to think of is you take everything inside and square it. So if I were going to rewrite this a little bit more properly, this would really be x plus 3 squared is really x plus 3 times x plus 3. Where the guy on the right, 3x squared, is really 3x times 3x. So now when I apply the area model to both of these, I'm going to get my boxes ready. This one on the left is fairly straightforward. We've been doing these for days. X plus 3 down the left and x plus 3 across the top is going to create a nice box that has 4 cells in it. And now I'm ready to apply that area model. X times x is x squared, 3 times x is 3x, 3 times x is 3x again, and 3 times 3 is 9. Hopefully you recognize and are getting a little better at recognizing the like terms here and here. So we will end up with an x squared, plus 6x, because 3x plus 3x is 6x, plus 9. When I work over here, this is going to be a fairly simple box because I just have one term going down the side and one term going down the top. I multiply the coefficients. 3 times 3 is 9. I remember I have my invisible math, my exponents of 1, so I end up with a 9x squared. So be careful when you're squaring things. If it's a binomial, you really have the two binomials together, and if it's a monomial, it's going to be a little bit of a simpler box. Let's go on to the next slide. 2x plus 4 squared. This is a lot like what we just saw. We have a binomial in here. 2x is one term and 4 is the other. So if I were going to write this out properly, 2x plus 4 squared is really 2x plus 4 times 2x plus 4. When we have that binomial times a binomial, the area model is the safest way to make sure we get this correct. So my first binomial going down the side will be a 2x and a 4, and my second one going across the top will be a 2x and a 4. So when I create my box, I have 4 cells. So let's go ahead and work right here. 2x times 2x. 2 times 2 is 4. I remember my invisible math, so I add those exponents and I get a 4x squared. Now if I do the top right box here, I'm doing 4 times 2x. So 4 times 2 is 8, so I'll have an 8x. Now if I do this bottom left box, I have a 4 times 2x, which will give me 8x. And then lastly, 4 times 4 is 16. I look for my like terms. Oops, that is not what I meant to do. Sorry about that. I look for my like terms. I have an 8x here, which will be like terms with this 8x. So I'm going to end up with a 4x squared. 8x plus 8x is 16x plus 16. Remember, this is in standard form because I do the term that has the highest exponent first, and then I work down to the constant at the end. All right, let's take a look at this one. This one's a little more interesting. I still have a binomial because I have x to the third is one term and the minus 4 is the other. And if you're doing a binomial squared, you know the proper way to write this out is really x cubed minus 4 times x cubed minus 4. I'm going to use my area model to make sure that everything gets multiplied properly. So down the left, I'll have an x cubed and a minus 4, and across the top, I'll have an x cubed and a minus 4. So when I finish the box, again, it's just a 4 by 4. I'm going to work on this upper left-hand one first. X cubed times x cubed, you multiply those coefficients. 1 times 1 is 1. You add the exponents. 3 plus 3 is 6. Now if I do this upper right hand corner, negative 4 times 1x cubed is negative 4x cubed. If I do this bottom left hand corner, I'm doing negative 4 times 1x cubed again. So you get a negative 4x cubed. And then the bottom right cell, negative 4 times negative 4 is a positive 16. The pattern that you may or may not notice is these guys in our problems have been the same. But now be careful here, when we combine like terms, I'm going to have the x to the, x to the 6, and then a negative 4x to the third plus a negative 4x to the third. If you did negative 4 plus negative 4 in your calculator, you'd get negative 8. I owe Mr. Pence $4. I owe Miss Breed $4. I owe a total of $8. So it's going to be a negative 8x cubed and then the plus 16 on the end. That's in standard form. That would be my answer. All right, here's the last one. This one's written a little different. It's more obvious to see that I have a binomial times a binomial, so maybe you'll recognize a little bit faster to put this in your box model, or your area model, I should say. The first binomial is down the side. It's an x and a plus 7. The second one across the top, it's an x and a minus 7. So I'm getting pretty comfortable with my 4 cells here. Fill in, I've got a little bit of invisible math going on, those exponents of 1. So now when I do this top left cell, x times x, I multiply the coefficients, 1 times 1, and I add those exponents. 1 plus 1, I get x squared. Now when I do this top right cell, I have negative 7 times x, which will be a negative 7x. The bottom left cell, it's a positive 7 times x. So it's a positive 7x. And then to finish off, a positive 7 times a negative 7 is a negative 49. Now here's where things get a little interesting, is my like terms here. I have a negative 7x and a positive 7x. Well, a negative 7 plus 7 goes down to 0x. So it's kind of like you have x squared plus 0x minus 49, but you wouldn't really write that 0x. You just have x squared minus 49. All right, so the final answer would be that. Although this isn't technically wrong, this is better because that 0x you don't really need. All right, so those were the examples for the day. If you need to rewind the video to copy any more down, please do so. Make use of your pause button. That is it for today's lesson. Check out Schoology. I do have a homework assignment ready for you. Please do your best to solve the problems. Get help when you need it, and submit the assignment. Have a great day.